Let's go to question 8. A Ferris wheel with a diameter 110 meters rotates at a constant speed. The lowest point on the wheel is 10 meters above the ground. As shown on the following diagram, P is a point on the wheel. The wheel starts moving with P at the lowest point and completes one revolution in 20 minutes. The height h meters of P above the ground after t minutes is given by this function, where a, b, c are all real numbers. Find the value of a, b, c. From this given information, we know the minimum height is 10. Maximum height is here. 110 plus 10 equals 120. So we can get midline. Basically, it's C equals 120 plus 10 over 2 equals 65. And amplitude equals maximum minus minimum over 2 equals 55. This is a cosine function. The wheel gets started from this minimum point. Then go to midline, go to the maximum point. So we get this pattern. From this minimum point, go to maximum point, then go back to minimum point. We know this is a negative cosine x pattern. Therefore, A is a negative, so A equals negative 55. The wheel completes one revolution in 20 minutes, means period equals 20 minutes. So B equals 2 pi over period equals pi over 10. So we get A equals negative 55. B equals pi over 10. C equals 65. Let's go to question 9. The height of water in meters is modeled by the function h of t equals a sine b times t minus c plus d, where t is the number of hours after midnight, and a, b, c, and d are constants, where a is a positive, b is a positive, c is a positive. A is positive means the pattern of this graph is a positive sine x pattern. For c greater than 0 means the starting point is on the right side of y-axis. Because negative c is negative, insider is liar. That's the reason the starting point is on the right side of y-axis. The following graph shows the height of water for 13 hours, starting at midnight. The first height tide occurs at 4:30, and the next height tide occurs 12 hours later, which means period is 12 hours. Throughout the day, the height of the water fluctuates between 2.2 and 6.8. Based on this information, we know the maximum point is 4.5, 6.8. All heights are given correct to 1 decimal place. Show that b equals pi over 6. We know b equals 2 pi over period. Based on the given information, period is 12. Simplify pi over 6. Let's go to B. Find the value of A. We are given the maximum height is 6.8. Minimum height equals 2.2. So amplitude equals maximum minus minimum over 2, 6.8 minus 2.2 over 2. We got 2.3. We are given this A is positive, so A equals 2.3. Let's go to C. Find the value of D. D is the midline. So D equals maximum plus minimum over 2 equals 4.5. Let's go to D. Find the smallest possible value of C. Since we know period is 12 hours, the horizontal distance between maximum point and this minimum point is half the period, which is 6 hours. So the coordinates of this minimum point is 10.5 or 2.2. Draw this midline. Y equals 4.5. This is the starting point because this is a positive sign pattern. We do know for a sin x pattern, the horizontal distance from starting point to this maximum point is p over 4. Which is 12 over 4 equals 3. This horizontal distance is 3. Therefore, this is 1.5. We know C is positive, so C equals 1.5. How to show your work? For question D, because this is 3 marks. Period over 4 equals 3. So 4.5 minus 3 equals 1.5. That's how we got this C equals 1.5. Let's go to E. Find the height of water at 12 o'clock. We are looking for h of 12. Let's plug into this function. Let's go to calculator. Answer is 2.87. Answer is 2.87 meters. Let's go to F. Determine the number of hours over a 24-hour period for which the tide is higher than 5 meters. We are looking for h of t greater than 5. Let's go to calculator. Type in the function. While you type in the function, make sure the variable you need to change into x In other words, here is x minus 1.5 instead of t minus 1.5. Enter. You got this graph. Then based on the information, you will change the window x-axis. It will be from 0 to 24. For y-axis, you can use this 0 to 10. It's good enough. So go back to menu, go to 4. Window setting. Minimum x value is 0, maximum is 24. We use this 24 divided by 10, it's 2.4, so we will use 3. Minimum value, let's use 0, maximum is 10. 10 divided by 10 is 1, then enter. Since we are solving h of t greater than 5, go back to this tab. f2 of x equals 5, enter. First of all, we need to figure out the intersections. Go to menu 6, 4, intersection. Menu 6, 4, intersection. The horizontal distance between these two intersections, then times 2 will be the solution. By graphing, we got these two intersections. Number of hours equals 2 times 7.08147 minus 1.91853. Answer is 10.3 hours. Let's go to G. A fisherman knows that the water height at nearby Folkestone Harbor follows the same sinusoidal pattern as the previous harbor, with the exemption that high tides and low tides occur 50 minutes earlier than the previous one. Find a suitable equation that may be used to model the tidal height of water at Folkestone Harbor. First of all, we know h of t equals 2.3 sin pi over 6 t minus 1.5 plus 4.5. Occur 50 minutes earlier since the unit for time is hours. So 50 divided by 60 to get 5 over 6 hours. 50 minutes earlier. So the whole graph translated to the left 5 over 6 unit or hours. So we get some graph like this. In other words, the new function horizontally translated to the left 5 over 6 unit. So the new function h prime of t equals 2.3 sin pi over 6 t minus 1.5 plus 5 over 6 plus 4.5. This means translated left 5 over 6 unit. So final answer, h prime of t equals 2.3 sin pi over 6 t minus 2 over 3 plus 4.5